Hello, and welcome to the AWS Education Research Seminar Series. I'm Marcy Collinson, your session correspondent and the Senior Scientific Research Programs Manager for the AWS Research Team. Today, we are delighted to have three presenters here to discuss accelerating time to research using CloudBank. Our first presenter will be Dr. Deepankar Mehdi, Program Director for the Computer and Network Systems Division at the National Science Foundation, followed by Dr. Michael Norman, Director at the San Diego Supercomputing Center and Distinguished Professor of Physics at University of California, San Diego, and ending with Dr. Sanjay Pati, who leads research initiatives for Amazon Web Services. We will reserve the last 5 to 10 minutes of the session for a Q&A portion, but please feel free to place any questions that you may have during the presentation in the questions queue in the GoToWebinar toolbar, and we will read them aloud later on. So without further ado, I'll pass the microphone over to Deepankar, or Deep as he likes to be referred to. Deep, please take it away.
Thank you, Marcy. Thank you very much. Okay, let's go to the first slide. Welcome everyone for joining this presentation. We're very excited to talk about CloudBank and what it is going to allow the researchers to be able to accomplish. But I want to start with a little bit of a background. So the first thing is that what we know with a cloud computing platform, that it actually is, provides a robust, agile, reliable, and scalable infrastructure. So this allows one to do more elastic data and compute-intensive research. Burst computing, those flexibilities are very beneficial to many researchers around it. They can also obtain efficiencies out of that, and with size being the Computer and Information Science and Engineering Directorate at NSF, we started looking into how we can make this more easily available to researchers. When I say researcher, I'm going to interchangeably use that word with another term we commonly use, principal investigator, or in short, PI. So currently a PI, if they want to actually use a cloud request, they have to do what we call is go it through their institutions. Now, where the difficulty is that when the request is granted, that the institution may or may not have a contract with a particular provider for which this researcher is actually going to more benefit from having that access to. And so secondly, this also is limiting in the sense that whatever that PI benefited from, no sharing of knowledge and researchers to the rest of the research community. So that's another limiting part of it. The other driver was that we had multiple reports that we actually looked into the NSF cloud strategy. And one of the things was from the National Academies of Science, Engineering, and Medicine. In their report, they said that cloud is extremely important for researchers. And we also funded 2 conferences on science, research and education in the cloud and future cyber infrastructure. So that sort of led us to create this solicitation, which was announced in the fall of 2018. The solicitation was 19-510. And so with that, I want to first give you the vision of how we wanted to see it. Let's go to the next slide. So our views about this is that what we call is a cloud access. So what we see in the middle is this cloud access entity. And it looks like a broker, but it has a more responsibility than a typical broker the way we look at it. On the left side, you'll see what we listed are the cloud service providers. Your usual suspects like the Amazon, Google Cloud, Azure, IBM. On the right side, you'll see the size-funded PIs, and they are all different PIs. So with the cloud access entity in the middle and then NSF, so you can now see that we have 4 different pieces to this puzzle. So the first thing is that we want to see is that the cloud access entity must have a cloud-facing function like cloud service provider. This is to minimize a lot of headache for the size PIs, okay? Secondly, on the other side of it, we need a community-facing function so that PIs can actually interact with cloud access entity. So that again goes to the minimizing the headache part of it, and that's where it is. So if you now look at the next step we want to do is that this is how the cloud access entity, which looks like a broker, is connecting between the provider and the PIs in the part. So now let's go to the next steps of how we are wanting to do it. So when you see the one here, what it says is that a PI request, or rather submits a proposal. As a part of a research proposal, the PI, she requests how much cloud credit she wants to get. And through NSF's merit review process, we are going to be able to decide if this particular proposal is going to be funded. Let's say it gets selected and funded, then the PI is notified that you're funded for your regular part of it, plus the cloud credit part of it, cloud funds that we're going to do. And we're going to let the cloud access entity know about that. And then this is going to be communicated both to cloud access entity once we inform them, as well as to the PI that this is funded and it is actually, you are able to use it. Once you get funded, we go to the next stage of what we like to see or envision it. First thing is that the PI is not the only person in a research project who is going to access it. The PI has postdocs, students, other collaborators. So PI has the ability to then create the accounts for all of them that the PI she would like to see. And for that, some training will be needed, interaction will be needed. They are going to interact with the cloud access entity. And then once they start using it, they're going to use up the resources, cloud resources. It could be the compute, it could be storage and whatnot. And once it is actually, since the actual service is provided by the cloud service provider, they are actually going to invoice it to cloud access entity, who NSF is already funding it. They will get paid for what it is. And then the PIs don't have to worry about that part at all. They not only the fund was allocated. So how do we see the goals and the benefit for the research community? First, I want to say that this is a pilot program for only the size directorate at NSF right now. NSF has 7 different directorates. We want to pilot it and see how successful we are and kind of what we do. The other important thing is that it must support all major cloud providers. And this is to eliminate the pain points, what we call account management, contract negotiation, all kinds of things you can think about. And where the cloud access entity becomes very important there is that because they're going to do it for all different researchers together, it's like bulk purchasing. So they can get a discount, and the part of the discount is going to come back to the PIs. So they actually will end up getting more than what they were allocated potentially. So the other important thing from the principal investigator's point of view, the PI, when they submit a grant proposal, is that instead of when they do it through their institution, depending on their agreement with the cloud provider, there's an indirect cost. So if you, let's say, request $10,000, there might be 50% indirect, 5,000 that goes to the institution. In this case, because we're doing it through the cloud access entity, the PI can request all $15,000 for actually using for cloud resources. That's another benefit to it. The other thing we envision is that the cloud access entity also takes care of the education and training. It's a very important component. Finally, when you go to cloud provider, what we cannot do with many instances is that we can actually give the research community a lot of freedom in terms of what type of resources and compute CPUs, processing units to use. Of course, your standard CPUs, graphic processing unit, that's becoming very important for a lot of scientific computing. FPGAs, field programmable gate arrays, those are actually very, very good. Tensor processing unit, as well as quantum computer, QPUs. Those are able to, the resources, if they want it, they can actually use it. So with that, I'm going to stop it here with the goal and the vision I talked about. Oh, sorry, I have one more slide. We went through a selection process after the solicitation was announced in the fall of 2018. It took us almost a year. And good news was University of California at San Diego was selected with UC Berkeley and University of Washington as the partner. And they called their cloud access entity CloudBank. Very nifty name. And they were able to actually get the domain name called cloudbank.org. That's also very nice. We announced it in August 2019. So it's a little over a year ago. And it's a 5-year program to start with. In the first page, there's a big part that involved portal development, where I was involved, worked with very closely, bi-weekly meeting with the UC San Diego team. It's a fantastic team. It has been a pleasure working with them to be able to get it. What's the good news? It's live now. It went up on production on August 1st, 2020. Even despite all the issues we face with COVID-19, we're on track to be able to actually go live as what was promised at by the team. And the other important thing is that there is actually a first award that went to University of Maryland. They are using the CloudBank, and that started on September 1st. So with this, now I'll hand it off to Mike.
Great, thank you, Deep. It's a pleasure to be with you this morning or afternoon, depending upon where you live. I'm Mike Norman, the director of the San Diego Supercomputer Center, and we are used to supporting researchers using advanced computing, but not in the cloud. The cloud offers some challenges. For one thing, the resource catalog is much larger than on-prem systems. Second, there is the transfer of real money to purchase those services, and we have to deal with that. And then third, the user support is far more diverse than firing up an app on a supercomputer. And so this is a new venture for us, and I'm pleased to tell you about it this morning. So the team is spread across 3 universities. At UC San Diego, 2 organizations are involved. The San Diego Supercomputer Center, who's taken the lead on the portal development and frontline user support. The UCSD ITS organization, that's the IT organization for the campus, has taken the lead on the contract negotiations with the cloud providers and also interfaces with our cloud reseller, Strategic Blue. University of Washington has taken the lead on education and training. They have a lot of experience doing this through their eScience Institute, and that effort is led by Ed Lazowska. And then finally, UC Berkeley, led by Kathy Yellick, is taking the lead on classroom use of the cloud. And of course, they have developed this marvelous Data 8 education platform that enables lecturers, teachers, professors to conduct their classes in the cloud. And so that's the trio. And then I mentioned Strategic Blue. This is a cloud reseller based in the United Kingdom. James Mitchell is the CEO of that, and he works very closely with the cloud providers on negotiating contracts that are beneficial to the researchers. And of course, Deep is our program officer. So one CIO asked me at a meeting, well, what problem are you trying to solve? And so for the researchers, we're trying to remove the friction associated with cloud access and account management and to hide the cloud contract negotiation, as Deep mentioned. And so it's administrative and financial friction. We want to help educate them how to use the cloud with documentation that is customized to their needs. And then finally, we are able to assist them as they're preparing their supplementary document that will go in with their proposal. So we help on pre and post award. For the NSF, we wanted to create a cloud access entity, as Steve described, We want to track usage trends and project future usage so that the foundation can make good decisions about future investments. And then finally, we just want to demonstrate the viability of a cloud access entity. This has never been done before, and so we're the guinea pig, and we're the canary in the coal mine. Now, for the cloud providers, of course, it's providing access to new users and new communities, but we will be helping offloading the high-touch nature of working with individual researchers, which the cloud providers do, but they're not really set up for onesie-twosie kinds of engagements. So that's the problems we're trying to solve. Next slide, please. And so I invite you all to go to our website, which is at cloudbank.org. This is the landing page. We are organized into 3 basic activities that you see in those graphics. The development of a user portal that deals with the administrative aspects of managing multiple accounts on multiple clouds. We deal with FinOps through our reseller Strategic Blue, and cost monitoring is also done through their financial systems. And then finally, the education and training effort. So we think of CloudBank as a set of managed services to simplify the use of the public cloud. Here's a list of benefits, also from our landing page. Deep mentioned most of this, but I'll just accentuate a couple of them. So we do help with the preparation of the proposal, specifically the supplementary document. Estimating cloud costs is not something anybody is very good at, so we work with them on that. Of course, once an award is made, we facilitate access to the cloud and track usage. We do support multiple clouds. Right now, we are integrated with Azure, Amazon, Google, and we're almost there with IBM. And so as a researcher, you might have accounts on multiple clouds, and you can see what you're doing all in one place, which is a unique capability. As I said, we help with monitoring resource usage, and through the Nutanix Beam multi-cloud platform, we can offer cost optimization advice. There's a variety of curated training materials on the website from both the University of Washington as well as the cloud providers. And we do provide classroom support through the Berkeley data stack. And of course, there's help desk support. So who can use CloudBank? It is primarily designed for NSF funded researchers, the PIs that Deep mentioned, and that's the left box there. And the access is through a formal proposal. But we also support educators through a lightweight process that we call a community access request. This is essentially an email to the CloudBank team to request small amounts of funds to support the delivery of a class, through CloudBank. And we do have discretionary funds that we use for that purpose. And then finally, there's an everything else category, which we call CloudBank Enterprise. This is basically a door that institutions can walk through and start discussions and negotiations to use the financial and administrative efficiencies of CloudBank to support institutional use, whether that be administrative, research, or educational. And so that is basically a conversation that we can enter into. This is the CloudBank workflow for the principal investigators. This is basically what Deep showed in a different format. I'll just make one comment about this. which is that when the NSF awards a project, the CloudBank, the cloud resources go to CloudBank and not to the home institution. That removes a lot of friction. And those funds remain on deposit at CloudBank and can be used flexibly depending upon the PI's decisions downstream. And so if, for example, a PI requests time on AWS in year one, and another cloud provider comes up with something new and interesting, their funds are still sitting in CloudBank and paid out on usage, and they can move to another cloud. So it provides a lot of flexibility for the researcher. The benefits for the PIs include being able to control, to create and monitor cloud accounts for their research students, their team members, who and set limits on their spend. One of the things that we heard from researchers is, it's a lot of hassle for them to keep one student from spending the account of the group. So that, we engineered that. This is all done through the portal, which we spent a year developing. The portal is really an integration of a lot of best of breed software tools, such as Discourse for community forum, Zendesk for help. It's built on Drupal 8, and we interface, of course, to community developed tools such as the Berkeley data stack. So the benefits for the PIs are at startup, during the project, and at the end. Okay, so next slide. So the portal is our pride and joy. It's a place that you can go to find out about the cloud and their offerings. There's a very elaborate cloud resource catalog, which presents a side-by-side rack and stack of cloud capabilities. You can access educational materials. There's the community forum, which I mentioned, and then there are links to provider tools. On the right, you see the user support model. It's a 3-tier model. Tier 1 is frontline user support done through help tickets. Tier 2 is proposal support and help with the design of the cloud instance to accomplish your research. That is dealt with through the University of Washington. And if it's classroom use, it goes to Berkeley. And then finally, if there are deep questions that have to do with vendor-specific technologies and platforms, we are negotiating agreements with the cloud providers to provide that tier 3 user support. I mentioned the community access requests. This is a way for an educator to request a small amount of funds to support the teaching of a class in the cloud. That request is done right from the CloudBank website. It'll be reviewed quickly, and then if the requester wants to use the Berkeley data stack, we hand it off to them and they create an instance for the class. And they've been using this software stack for years to teach 1,000 students per semester about data science. So it's hardened and scalable. This is a slide on the Berkeley data stack. It integrates a lot of best of breed open source software, including the Jupyter Notebook developed at Berkeley. So at this point, I'm going to hand it over to Sanjay to talk about the AWS view of this project and how they're integrating with it. Thank you.
Thank you so much, Deep and Mike. Before I talk about benefits of using cloud, I just want to mention to this audience that this is really a historical step taken by the community at large. It started with Cloud Access Model, led by the community, led by National Science Foundation, and now the project itself with UCSD, UW, as well as UC Berkeley. It's a historical step. It's not so simple to build that at a national scale. So I really want to thank everyone who contributed towards this. From my point of view, I'll give you a couple of examples of the benefits we have seen. So the way typically cloud provides, and it's valid across any cloud provider. Since I'm from Amazon, most of the examples here are from Amazon. So one of the major benefits of working with the cloud is actually heterogeneity in compute resources or computational resources. In Amazon, for example, we look into computational resources in terms of what we call batch-like system like Amazon EC2. Also container-based approach where we have seen singularity is rising up in many of the communities. So Amazon and other providers do provide this container-based approach. We also provide the look into that in serverless computing that way. And within the resource itself, if you look at it, I'm sure you all know about that, but I just quickly want to say this so that later on we'll use these things. So as you know, CPUs typically have 10 to 100 processing cores. A GPU typically has roughly about 1,000 of processing cores. And the FPGA has a billion programmable logical units. There is no predefined instruction straight, but if we can manage to use these processing units across CPU, GPUs, and FPGAs, we should see an enhancement in our time of execution. So I'll briefly mention about a couple of examples. And with cloud also, you have access to all of them. So like in Amazon, we have a general purpose CPUs, compute optimized, storage optimized, accelerated computing is categorized under GPUs and FPGAs, and also memory optimized processing units. Here is one example. Researchers from Clemson University, they were trying to study topic modeling or natural language processing. And in order to study that, their own university's infrastructure was not enough. So what they did is they used AWS in this particular case, but in homogeneity in the CPUs, and elastically scaled up to 1.1 million cores. That was using a Spot instance, which is a unused capacity in Amazon, just using one data center region, US East. So that particular study was approximately done in roughly about 2 hours or so. And this should have taken them roughly a few months to do it. And the outcome is that they managed to study NLP for 17 years of all computer science data, including 3.2 million words. So those whole classifier could be done within 2 hours, which would have taken within the campus infrastructure several months or if not years. This is another example of elasticity. IceCube is an experiment which has detectors built under the earth. So unlike telescope where you get the information from the sky, in IceCube there are detectors built in underneath it, and they trap neutrinos. In this particular study, they used roughly about 51,500 GPUs, completely distributed fashion across 8 generations of NVIDIA GPUs using Amazon, Azure, as well as GCP. Imagine you want to do that using a supercomputer. For example, the top #1 HPC system is Summit and has a nominal performance of roughly about 400 petaflops at 32 bits. This is roughly about 95% of that capacity, and they did it, within an hour or two. and they can shut it off. So you can get the full access of distributed computing using cloud. And here is the article. This was actually funded by National Science Foundation. Here is the third example I'd like to give you on FPGAs. So as you know, a given genomic sequencing on a standard processes like CPU will take hundreds of CPUs running for months at a time. So Children's Hospital Philadelphia, as well as ENCO Genomics, they actually run their workflow on FPGAs or Amazon F1 instance, and they could finish that within 2 hours and 25 minutes. This was the fastest genomics analysis ever done. They also got a Guinness Book of World Record. So it really depends on the workload the scientific community is using. Sometimes it's important to be elastic, but it's also sometimes use latest generation processing unit that can accelerate the time to science. Since we are talking genomics, somebody can ask, is cloud secure and all? Absolutely. Here is a classic example of virtual research desktop. UC Health started using it in a very HIPAA compliant environment that uses both analytic infrastructure from Tag Bio, but also the whole environment is fully HIPAA compliant. Details are there in this particular link. Cloud not only give access to these resources, but also quantum processing unit. So for example, Rigidity, it's a universal gate-based QPU based on superconducting qubit. What you see here is actually a topological structure. Each edge are connected to 2 folds, but also a 3-fold around the connecting structure. And this has current time of 20 microseconds. So cloud can provide access to these devices as well. Here is IonQ. IonQ is actually, you can do quantum computing by trapping a given ion and connecting them by laser system. And since it's a laser system, you can connect many devices at the same time. There's not much penalty, and that's what they did in IonQ. So it's a multi-connected laser system that is available in cloud. In Amazon, for example, we call it Amazon Bracket. We do provide access to all the 3 systems like Rigidity, IonQ, as well as quantum annealers like D-Wave. What's given here are the number of qubits accessible by those systems. For example, 5,700 qubits for D-Wave, similarly IonQ. And what is given here is given regions where it is available. So any researcher via CloudBank should be able to access this anytime they wish. The people say, what are the applications? There are many applications of quantum computing. For example, machine learning in several places, artificial intelligence, in chemistry, the new fertilizer or catalyst design, biochemistry, finance, healthcare folks are using it. So one can really perform many of these studies using quantum as well as modern resources as we talked today. Coming back to CloudBank, currently there are 3 NSF solicitations that are completely CloudBank eligible. So one is cyber physical system, SICE, all core program. SICE is a computer information science and engineering directorate, and all of their core programs via this solicitation is cloud eligible. Similarly, there is CSSI, cyber infrastructure for sustained scientific innovation, is also cloud eligible, as you can see. So the question is, how do we apply, right? So in order to apply, one need 2 important things. One is you have to select which cloud provider you're using. Second is create a supplementary document. And that document tells you a technical justification, how you're using it, but also cost calculation, how much you will spend such that NSF can fund it. So let me give you one example. So here is one example. It's an HPC cluster. Imagine there is a faculty who is in physics department and want to build his own HPC cluster. He has, let's say, 10 students, a postdoc, so he will need roughly about 10 desktops. He also wants to store 1 petabyte of data, for example, in archive mode. He also needs, for example, 10 terabytes of object stores. Data egress, if with cloud and with the university relationship we have, almost every cloud have, you can get up to 15% of the egress waiver. In this particular example, roughly about 200 terabytes per month. Imagine he wants to create a HPC cluster with a given memory as well as given systems. All we need to do is go to a calculator. So let me show you a very quick calculator. So basically, you go to a given calculator and add a given service. So you can just say add a service. Let's call it S3. This is the storage one. You can configure it. It's as simple as this. The way to go to Amazon Calculator or the calculator is just from the NSF website, but also you can Google it. So once you go to the calculator, you can add a standard S3. You can put a given amount. For example, in this case, let's say 100 terabytes per month. And then you'll know the total cost here. You can put a data transfer. Maybe you want to have 100 terabytes you want to transfer out. Data transfer in is free in almost every cases, so you can pick any amount you like. But data out will be charged, but given that our university relationship, it will be waived. So then you get the total value, and that gets total added here. You can delete it, and in this particular example here, I added, for example, S3 with 100 terabytes per month, with a Glacier about 1 petabyte a month, as well as data transfer is roughly about 1,500, 1.5 terabytes, and so on and so forth. So this is the total cost, as you can imagine. And this calculator will give you the total value, and that total value you can put it in your calculation when you add the supplement document. Here is another calculation I wanted to show you quickly. Is a study they want to study quantum computing with using 2 different QPUs. So they want to study, for example, dynamic decoupling of 1 or 2 QPU states. So for IMQ, the costs are given here. They can calculate the cost per task is about 0.3 cents. If you calculate it totally, you'll get roughly about total cost is about 1,100. Similarly for rigidity, and if you add them together, it's roughly about $1,700 per month. For a year, you can do it roughly about 21,000. And the details of the pricings are here, but also in NSF web pages. Here is a third mock example of supplement document where one need to provide that this is my 3 years budget of using CloudBank, and our team is 2 faculty, 3 postdoc, 4 students. We want to use, for example, container with Kubernetes. We'll use dedicated development instance for Postgres database, as well as few VMs for the cost. So for a cloud cost for 3 years using AWS rate, using the calculator I showed, you can see for object storage for 50 terabytes in their case is 4,800. They enhance to 125 terabyte and so on and so forth with the total value here. At the end, please don't forget to add up and write the total. So this is something like that will be needed in order for researchers to apply along with the technical documentation of their application. We will provide some of these in a given form such that we can download it as well. But these are mock supplement documents. One of the crucial items which is needed almost every NSF solicitation, including these ones, is actually a data management plan. This does not go into the supplementary document. Here is one example of data management plan. One second. So here is in this particular example, the bulk of the data, and this is needed almost every solicitation. So here is, for example, the bulk of the data in this project will be pre-existing data collected from individuals and organization. It will be made available to public. It's important that any study, especially in general sciences, it's good to share the data. So we'll share the data based on permissions from stakeholders and data owners. We'll also use data lifetime management policy that consists of a set of rules. So for example, if data is unused for 3 to 4 months, it will go to archive. And thus we calculated a 1 petabyte of Amazon Glacier, which costs roughly about $48K per year for next 5 years. So data management plan is extremely important. This is just an example or a mark of that, but one can use similar example for the proposal. We'll try to make these also available there so that people can use it. Other benefits of CloudBank, once you're awarded, for example, in this previous case, let's say the total value awarded is, let's say 184, right? 184K for 3 years. In year 1, they need to spend, let's say about 1/3 of that. So about 90K, right? So in CloudBank, you can see yourself, your own funds. You can access your billing accounts, how you're using it. You can monitor your usage. But also you get also cloud catalog of any other services you want to use. It's very simple. Also, all the training materials. Let me show you a quick link to the training materials. So if you log into cloudbank.org, they have a whole set of training material. This is not only for researchers who got the award, for anyone who should be able to use it. And this uses CI login, so you should be able to, any researcher will be able to using the university login or any other account. So in this particular case, you want to use any training materials, even though you don't want to apply, right? So you can just go to the training area, and for AWS, for example, you can click it and you can get all the information on getting started with AWS, architecture, machine learning on AWS, and there are tons of materials on compute, storage, various information on machine learning, like SageMaker. There are workshop materials, there are notebooks available in GitHub, there are AI services, one can access it. So please have a look, even if you're not applying it, and this will get you started with the cloud. Coming back to but once you're awarded, for example, let me get back to the screen. Once you're awarded, you'll also get an account like this, where you are the PI, which is on your right corner, and you will know your spend, monthly spend, as well as your total budget and how you're doing with respect to a given set of budget. CloudBank is also available for enterprise. So imagine you don't want to use, you're not going by NSF, but you really want to use CloudBank for your own institution. There are enterprise ways to access CloudBank. That will include several help with some services like architecting the given architecture, functional engineering, and several advisory services. The details for the CloudBank Enterprise can be found in the bottom. So with that, let me stop. Please apply. These are the 3 core programs are opened. I'm absolutely sure more will come, but also join the community and help build this community. Thank you.
Sanjay, let me add a couple of things about the program. This is a good place to talk about briefly. Sure. We have, as I said, it's a pilot program, so we wanted to start with a few of them and see how it works out. We already did one under the Smart and Connected Communities solicitation. That's the one that got awarded with the University of Maryland. That's already in production. Cyber Physical System is an active solicitation right now, and they have, I think, a deadline coming up soon. The SciSE core program means all research under the Computer and Information Science and Engineering Directorate that we added it to give access to as many researchers as possible. And then that one has a deadline for the medium coming up in November, but for the small projects, which are $500,000, there's no deadline as long as they do it within the fiscal year. So by fiscal year, I mean the federal fiscal year in the United States, October 1st to September 30th. And then the cyber infrastructure for sustained scientific innovation, we're very excited about this one. Also because it goes to the infrastructure part of it and for scientific innovation. And we are also considering another one or two to be added very soon. So I'll stop it here so that we can open it up for Q&A.
Thanks.
Wonderful. Thank you all so much for the great presentation. And I did want to let the audience know that I put a link to not only our research and technical computing homepage for AWS in the chat, but I also put a direct link to our automated request form for a letter of collaboration to submit with your solicitation applications. So feel free to let us know if that's something we can help you with. Now I'm going to just dive right into the questions. We do have quite a few, so let's try to get through them. This one was asked pretty early on, but maybe we can speak a little bit more to it. It's, can you speak more to supporting indirect cost distribution with CloudBank? And it's not pointed at anybody.
Yeah, I can address that.
Go ahead, Mike. You go ahead.
There are no indirect costs on the cloud resource request. That's per NSF policy, so IDC free.
So let me give a slightly different way an example. Let's say our small core program, a small size proposal for the core program, the budget is limited to 500,000. Let's say you want $100,000 worth of cloud funds. So you will request $400,000 for your student support, other things that support for travel to attend conferences in your 400,000, summer support and whatnot, and then 100,000 under the cloud funds you're going to request it. Now, if you were to go through your institutions for requesting that 100,000, depending on institution's policy, you might have different rules on it. Typically, it's about 50% indirect. It could be less. So if it was 50%, so you could not request 100,000. You will request what? Less than that, about 67,000. So in a sense, you are getting a gain out of being able to go from 67,000 to 100,000 by directly going through the supplementary document to request cloud funds, and that NSF will allocate directly to CloudBank so that you can actually use it.
Wonderful. Thank you both. Next question. This helps tremendously with first mile of cloud, but how do PIs get technical support for infrastructure and training on the various platforms? They can create the applications or run the analysis, but the underlying infrastructure development is often not in their wheelhouse.
Yeah, that is the missing link. I will say that is the big challenge. It's the flip side of the tremendous variety of resources available. The training is the hardest part. And so we're just going to take it as it comes, and we're going to provide the kind of technical support that we know how to do. And this includes the University of Washington, who has been doing this kind of support for 10 years through their eScience Institute. But at some point, it will spill out of our expertise, and we're going to have to work with the cloud providers. And so CloudBank is negotiating support agreements with all of the cloud providers for that level of technical support, and it will be available on request.
Yeah, I can add one more thing. For example, for AWS, we are part of this help at cloudbank.org. So when you request a technical support, it also comes to us if it is AWS, and we will provide all the technical support needed for that particular project. So we also provide support via the community forum. So in case you have questions, which can be done offline, so that we will also address via the forum itself.
So if
and
I may add
a couple of old examples in the forum as well. Yeah, go ahead, Deep.
Now, if I may add to what Sanjay said, we anticipate the other cloud provider like Google Cloud Microsoft Azure and IBM Cloud, to also provide that sort of help. And because our impression from when we at NSF had conversation with all the cloud providers, they are very eager to see researchers being able to benefit from a platform like this. So they believe that it helps science. It actually indirectly helps their cause as well. And we know that students who get trained through those research awards end up actually being hired by these companies. So they have there are ways they benefit from it. So I'm hoping and anticipating that this will take place.
Great, thank you guys. This is more of a comment. AWS Bracket is a brilliant approach to quantum computing and simulator. It's a great assistance. So thank you for adding that. Next question. Dr. Norman's slide mentioned Nutanix Beam. How and what is the functionally doing in the CloudBank ecosystem?
Yes, so Nutanix Beam is a third-party multi-cloud cost monitoring tool that is integrated into the portal. And it was developed primarily for businesses to monitor and optimize their cloud spend. And so it's very sophisticated in terms of its ability to drill down and address specific questions. So I hope that's a good enough answer. It's used by hundreds of companies to monitor and optimize cloud spend, and we've just adopted it as our monitoring system.
Great, thank you, Dr. Norman.
Of course, it's integrated with the cloud providers' accounting and billing. So, it's not presenting different information. It's just presenting the same information in a different format, all integrated.
Thank you. Is it possible for projects that are currently funded to take advantage of CloudBank?
Let's see, that's probably, I'll try to, at this point, yeah, I guess I have to take it as an NSF program director here. If you are currently funded by NSF, we do not have anything explicitly stated for being able to add something, but we are also looking into that, if we can do something through what we call as a supplemental funding. So thank you for bringing it up, and please shoot me an email. My email is dmedhi@nsf.org, so nsf.gov. So please do, and I'll be happy to get that. Good question.
Great. Next question is, how do you prevent a graduate student from using up all the project budget in the first week?
Yeah, well, there's two parts to that answer. One is our account management module in the portal enables the PI to create sub-accounts and to break out and to put spending limits on those accounts for individual group members. So that's the coarse grain solution. But then, of course, that student might launch 1 million VMs and overspend faster than we're getting reporting from the cloud provider. So we have to actually put some intelligence into the portal to do real-time usage monitoring based on live instances, and we will be sending alerts and possibly just putting on the brakes if we see something very unusual.
Yep, this was a very important, good question. This was a very important requirement from our NSF side. I worked very diligently with the CloudBank team, and I think we have a pretty good solution there. And so, by as Mike talked about, putting a spending limit on each student, and not only that, the PI actually gets a report depending on how much different kind of alerts, depending on how much fund is remaining in her account actually. So so we are actually had already addressed during the portal development.
Great. Next question. I have built a platform for a specific health-related application using my NSF Career Award. It uses AWS service to predict injury based on wearable sensors. Now that the app is built, I want to evaluate the predictability of the framework to predict injury, which is more of an NIH topic. Does CloudBank work with NIH, or is there an NSF and NIH pipeline where cloud-based technologies can transfer?
No, we do not work with NIH. We have no agreement with them. However, we did design the portal for multiple funders. Currently, we only have one, that's the NSF. But if the NIH wanted to fund their researchers and let them use CloudBank Portal, we would be happy to do that. Since we're basically 1 year old, that hasn't happened yet, but if it does happen, we could support that. The other part of the answer is, let's suppose you wanted a little bit of resource to demonstrate something for an NIH proposal that was funded by NSF. We could entertain a community access proposal, which is this lightweight request for funds, for discretionary funds. And so it would just be a conversation and a judgment.
All right, we have another question on that note. Will the NIH follow the NSF's lead on this approach to grant infrastructure funding?
That's up to the NIH. What I know about STRIDES is it's fundamentally focused on intramural use of cloud, the 18 institutes and all their investigators and so forth. Of course, NIH makes extramural awards, but my understanding is currently STRIDES is mostly focused on intramural. We'd be happy to talk to them and work with them through the CloudBank Enterprise channel.
If I may add something to what Mike said, was that when we envisioned this whole idea, remember I said it's a pilot project. Our hope was that this model of the broker in the middle that does more than just a standard broker plus sort of an idea, is that actually allows such a function, so that other federal agencies may end up becoming part of it. And that's why when we started doing this discussion after Mike's team was awarded this proposal. By the way, Mike is the PI for the CloudBank project, in case you didn't catch it. And so I work with it to make sure that we keep those in the portal development from the very beginning, keeping an open eye so that others can actually join it. So that's the hope.
Wonderful. Well, I want to thank you. Oh, sorry. Go ahead, Sanjay.
Yeah. Good remark. Mike, I mean, STRIDES has both components, internal and extramural. And I also, like Deep said, I also envision that that more and more federal agency will start using it. STRIDES is not same as CloudBank. I mean, CloudBank is much more elaborate in training, education, as well as helping the community to grow, right? And that's very vital. And it's a monumental step taken by Mike and others, but also it's for community to also jump in and help build this as a process.
Fantastic. Well, I want to thank all three of you again for such a wonderful presentation. You can find information about upcoming sessions as well as recording and presentation decks on our series homepage, which I put a link to in the chat. And if you have questions about past presentations or ideas for future presentations, please email us at aws-wwps-seminar@amazon.com. And then please save the date for our next AWS Research IT training series session on Ronin, Research Computing on the Cloud. And that will be presented by Ronin CEO and co-founder Nathan Albrighton, as well as Tara Madhyastha, Principal Research Scientist at AWS. And it will be held on October 27th from 9 o'clock to 10 o'clock a.m. Pacific Standard Time. And if you registered for this event, you will receive an email with a registration link for that session once it's available. We want to thank you all for joining us today and supporting these series. And we hope you have a wonderful rest of your day. Thank you.
Thank you. Thank you, Marcel. Thank you, everyone.
Thanks.